So in this section, we're going to look at binary trees. Now, this is a definition that comes from section 7 of the course, sequences and series, and it relates to summations. So it's actually the last one here, part D. Now, it rarely gets used in, sorry, let's go back here. It rarely gets used in part D, in the sequences and series part of the course, but it actually is useful in the trees part of the course. So it is this one here. Okay, it's probably overdone it there a bit with the highlighter, but it's that one there. So x, the summation of x to the power of r equals x of n plus 1 to the power of n minus 1 all over x minus 1. Now let's just say for argument's sake that that was 2, x was equal to 2. Let's write that out. So that is the sum of 2 to the power of r from r equals 0, and that is equal to 2 to the power of n plus 1 minus 1 over 2 minus 1. 2 minus 1 is just 1, so that just actually cancels out. So I'm just going to erase that there straight away. Oops. So it's 2 to the power of n plus 1 minus 1. That's equal to 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2, and so on, all the way up to 2 to the power of n. So if we want to evaluate it for 2 to the power of 9, let's say, where n is 9, sum of 2 to the power of r equals 0, that is equal to 2 to the power of 10 minus 1. 2 to the power of 10 is 102524, so 1024 minus 1, that's 1023. So what's that? That's 2 to the power of 0, 2 plus 2 to the power of 1, and so on. By the way, just a quick remark, 2 to the power of 0 is equal to 1. Just in case you forget that. Right, what we're going to do now is look at a question where this is relevant. So let's move that back down there. A binary search tree is designed to store an ordered list of 600 records at its internal nodes. What record is stored at level 0? I'm just going to give you the answer to this quickly. It's the floor function of 600 plus 1 divided by 2. That's the floor function of 300.5. That's just 300. What records are stored at level 1 of the tree? So 2 to the power of, sorry, what am I talking about? So records 1 to 299 are stored in the left hand side. The right hand side, records 301 to 600. Now, using a formula we used earlier, with this, these corresponding to a and b, the floor function of a plus b over 2. In this case, we have 300 over 2, the floor function of that, and that's 150. This side here we have 901 over 2, that's 450.5. Floor function of that is 450. So what records are stored at level 1? 150 and 450. It's a good idea to show your workings actually as well. Now, determine the number of records stored at level 9. Well, at level 1, at level 0, there is 1 record. At level 1, there's 2 records. At level, let's put like the level here, and number of records. At level 2, there'll be 4 records, and so on. It's actually, for the level number n, the number of records is 2 to the power of n. So level 9, there'll be 2 to the 9 records at level 9. And that is equal to 512 records. Okay. Now, how many records are there between levels 0 and levels 9? So if you consider how many are there between level 0 and level 9, well, we actually answered that in the last page. There are 1023. So it's not actually asked here to determine the record stored at level 9, the number of records. So there's 512 of them there, and but it's actually just an additional question: how many records are stored between the root and level 9? How many of them there? And the answer would be 1023. 1 plus 2 plus 4 plus 8, all the way up to plus 512. It's handy to know it doesn't come up. It hasn't come up that much, but it could come up. That's why I'm sort of looking out for it. Alright, that's the end of this presentation.